My name is Andy Rosser, one of our support engineers here at DISTI, and today I'm going to be talking to you about a rather in-depth topic, and that would be the GL Studio API. We're going to be going through today and covering this topic in many different lights. The first one, I'm going to go ahead and show the many ways you can view the API, including the header files that we have, plus going through the documentation. And then we're going to be using this API to solve a problem. Our problem is we're going to have a solution, a project, that has many different objects. And we'll say we want to change the color of every single object in the scene at the same time. This might not be such a big deal if we have maybe 3 or 4 different objects, but if we have hundreds of objects or hundreds of GL Studio objects in our scene, we're not going to want to call each of them out by name. So we're going to be using the API and a few other things inside GL Studio in order to make that happen. And then we're going to go ahead and conclude by showing how to create a custom GL Studio base class, also along the same topic. So as we begin, I'm going to go ahead and show my screen. Now, on the screen, I've navigated to our GL Studio's include directory. By default, this is C, Program Files, DISTI, GL Studio 4 include. Inside this folder, we have all the header files that are used in GL Studio, including the definitions of all of our basic primitives, such as our group, our GLS polygon, our light source. Everything that you could possibly need to use in your own separate base class is located here. This is also a good reference to see exactly what functions are within each object and what each object derives from. Of course, this isn't the only way to do this. In addition to looking inside the include folder, we can also, inside the GL Studio editor, go to Help, and then choose any of these 3. I prefer to search by index. And this will bring up the GL Studio help file. Simply going in here and searching for an object, such as the GLS ellipse, will bring up a set of topics. In this case, we'll look at the class reference. And this will bring up a Doxygen create a list that shows all the information you could want to know about GLS ellipse, plus includes a link to the header file that we just viewed a few moments ago. So we're going to be coming back to this in a couple of moments. I'm going to go ahead and leave this up and just move it off the side of the screen a little bit. The first thing we want to do is we're going to start with our little project here. I've started out by creating a simple project. We have 2 groups, one for my text objects, which is one text box and one text grid. And then we have a group of primitives showing one ellipse and then 2 polygons, one of which being a rectangle and the other one being a free-form triangle. What we're going to do is we're going to write a couple of methods that are going to help us to change all the colors of these things at runtime. So the first thing we know we need to do is create a property. We're going to create a property for the actual color. So we'll go Add Property. And then for the type of property, we're going to make this a type GLS color. We'll name the property color. And we will give it a default value. We'll say call GLS Colors Constructor and pass it all black, 000 with an alpha of 255. Now in this case, we're not going to be storing this value. We're just going to be setting it. So we will not need a member variable, and we will not need a get method. So what we'll have is a set method, and we'll be setting this shortly, so we'll be coming back to this. The other thing we're going to need is a means with which to set the color of all these objects. We'll go ahead and make this a method. Make it return nothing. The arguments, we will want to definitely take in the color. We'll make it constant. Constant GLS color pointer, name color. Now, how we're going to do this, we're going to go ahead and take an approach with which we navigate through all the objects in our scene and set these colors. This will include groups. Anytime we see a group, we're going to go inside that group and actually change the colors of every object inside that group as well. So this is going to be a recursive method, and as such, I'll actually name it SetColor Recursive. And for the arguments, I'm going to need to add one more argument. In this case, I'm probably going to want to add the display object that we're actually changing. Now, where did I get display object? Let's go back to the help file, and we'll actually pull up display object. We see there's a lot of different things that reference display object, because display object is essentially the main base class for all GeoStudio drawable objects, including our polygons, our spheres, text, group. All these things derive from display object. So we know that if it's something that we're going to need to change the color of, it's going to be a display object. Pull this to the side. We're going to be going back to it later. So we have our SetColor method, which takes in our display object pointer. The display object pointer in this case will relate to any one of these objects. And then we have our color that we're actually going to be changing. So before we write this, let's go back to our property. And we're going to need to put something in for the set method, or for our set method for the property color. What are we going to do here? Well, one thing we can do is just simply say SetColor Recursive. And we know we're passed in a GLS color by reference value, so we'll go ahead and pass the address of that color. But we have one other property. We have this display object. What do we fill in right here? The answer to this, once again, comes back to our API. If we pull this up, we know that all of our GeoStudio objects derive from component base. Looking through here, we will find actually, I take it back. We'll do this a little bit easier. Instead of doing this, we'll go ahead and generate at this point. This won't compile yet. We'll be able to see a little bit more about what's going on. So we've created our two files, color change app, CPP, and .h. Let's open up the header file. In this case, since this is an application, it doesn't derive from component base, as I originally said. It derives from GLS display frame. Now let's look at GLS display frame a little bit closer. Once again, we could do this one of two ways. We can either look inside the includes, which I'll go ahead and take that route this time, or of course we can go back and look at it through the help. GLS display frame .h. Now we're going to go through here, and we're going to find, we almost have to know that there is a single group that encapsulates all of our, or that holds all of our different display objects. We just don't know what that is just yet. We have our OpenGL window. Here's our GLS display frame. Look through here. We have a couple of protected members. We can also see that this derives from runtime display frame, so if we strike out here, we can always look there. And I believe that's what we're going to have to do. Let's dig a little bit further. Now the upside, of course, to having me do this right here is that after you've seen this, you'll actually know where everything's located, and you'll also get a little bit of an insight into some of the extra things that you have given to you with every single application. So we know runtime display frame derives from display frame. We don't have anything that's a group here. Let's go down one more level into display frame. This time we have our class display frame. This thing doesn't derive from anything, so if we don't find our actual thing here, then we are in trouble. But looking right here, we have a public variable, a group pointer for objects. According to the comment, this is the entire object hierarchy for the display frame. So we can safely assume back here that this entire setup is actually in its own group named objects. At least according to this. So let's go ahead and remove this group. And inside color, we'll go ahead and pass objects. So now we know exactly what we're passing. We know we're given an objects variable that stores our group, or it's pretty much a group of all of our objects. Now we need to know what we're going to do with it. Inside SetColor Recursive, this is where all the work is going to happen. The first thing we're going to want to do is determine inside our SetColor function is what type of object we have. We can do this a couple different ways. I actually prefer to use dynamic cast. So let's see, we know we have groups, we have GLS text boxes, we have GLS text grids, we have GLS ellipses, we have GL polygons. This is a lot of objects, and I'm going to go ahead and stop right here. And once again, we're going to go back to the help. This time, let's go ahead and go back to display object. And let's see what we can do to simplify things a little bit. Inside display object, we have this class named text. Text is actually the base class for GLS text grid and GLS text box. As we can see, text box derives from GLS text, which goes down further and is also a polygon, which is also a display object. For the text boxes, we're going to want to set the color of the text itself. According to our public methods, we will have a function that does just that inside GLS text, simply called TextColor. Takes in a single constant color by reference. So this is the function we want for both text box and text grid. So let's simplify our method a little bit. Instead of having a GLS text box and a GLS text grid, we're only going to search for a GLS text. That'll cut down on a little bit of our work. In addition, GLS ellipse actually derives from GL polygon. We find this out using the same technique. I'm going to go ahead and just simplify it, or go ahead and do it just to save time. So we've now cut down our list of objects down to 3. A good place to start. We have our group, we have GLS text, we have GL polygon. What I'm going to do is create variables of all 3 of these. So we have our group pointer, we'll call it group. Our text pointer, we'll call it text, polygon, polygon. Now what I'm going to do here is use dynamic cast to actually determine whether or not our object is one of these types. For those out there that have never used dynamic cast before, what dynamic cast will do is attempt to cast its parameter, in this case our object, into the type specified. So we're creating a group pointer. We're trying to cast our display object as a group dynamically. What this will do is if it can create this cast, it will go ahead and cast the object for me. If it cannot create the cast successfully, what it will do is return null. And I'm going to be using this later on to actually check for null for these objects. So quickly, we'll go ahead and create our GLS text and our polygon. So we've got our 3 variables. The next thing we want to do is actually check whether or not we actually have a type of that. So we'll say if group, which is exactly the same as saying if group is not equal to null. We'll also want to say else if it's a text, and else if it's a polygon. Notice that I checked text before polygon. If we notice back from the help one more time, GLS text derives from GL polygon. So we're going to want to check for the more specific one before we check for the lesser specific one. So we're doing text first, and then if it's not a text but it is still a polygon, we'll go ahead and continue on and do this check as well. So we have different things we're going to want to do for each of these. Group is going to be the most complex, so I'll come back to it. Text is simply saying, okay, well, we have a text. We're going to want to set its text color according to that method we looked at before. It takes in a constant color by reference. We have a color pointer, so we'll simply dereference the pointer and pass in color. Polygon, we have 2 things we can do to it. Of course, what are those 2 things? Well, let's actually take a look. GL polygon, we can either set the color of the line or the color of the fill. We'll actually go up to display objects and take a look at this. We have set color, which will actually set the line color, and then we also have set fill color, which will actually set the specific color for the inside of the object or its fill. We'll go ahead and set both of those. We'll say set color. Set color had several different overrides. One of them was a constant GLS color by reference. So once again, we'll dereference color. And set fill color, exactly the same thing. As long as I can spell it right, of course. Dereference color. Now what's left is the group. Groups can be a little bit different. What we're going to do inside group is actually iterate through the group and call our recursive function on anything or on any objects inside this group. So if we are a group, the first thing we're going to want to do is actually find out how many objects are inside this group. So we'll have our unsigned integer for count. We'll call groups count method. Once again, this is a method that can be seen inside the API, inside the help. At this point, I'm going to go ahead and discuss all the functions, but I won't constantly reference the help. So we know that we have a count method. The other thing we know is that we actually can use the brackets operator on a group to actually get an element inside it. So what we want to do is go for, run our for loop. This is one way to do this. Okay. Unsigned int I equals 0. I is less than count plus I. In here, like I said, we'll just go ahead and call our SetColor Recursive function again. And this time we're going to want to pass it two things. We know the second one is the color. The first one, groups of I. Not quite groups of I. We're actually going to want to dereference this because this itself is a pointer. We want to get the value of it. So we're going to dereference group and then take its whatever object is inside its array at index I. And that's really all we have to do inside this function for this time. I've already done a couple of things for us. I've already included our utility functions, glsutil.h. And inside calculate, what I'm going to do is create three integers, one for red, one for green, one for blue, and then ramp these values from 0 to 255 at several different time values. Once we do that, we'll go ahead and set the color, call the color property, pass in the red, green, blue values with an alpha of 255. So tracing through this, we go to calculate, create these values, call color. Color comes in, simply calls our SetColor Recursive, and starts it at the very top parent group, which will then filter down. First it will find the group for text objects, go in there, set the color of our box and our grid, pop back out, go to the next object, which is also group, come inside here, set our colors for our ellipse and two polygons. At this point we should be good. We'll go ahead and save and generate our code. We'll go ahead and hop back out, actually open our Visual Studio project. I'll go ahead and run it in debug, and assuming I didn't make any mistakes along the way, we'll find out very quickly if I did. It looks like I did, and it's a spelling mistake. Okay, let's go ahead and hit that really quick. Another use of syntax coloring in GL Studio 4. This did not turn blue. I should have caught that very quickly. We're going to go ahead and rename that dynamic cast like it should be. Regenerate the code and rebuild. Okay. Let's see, I'm getting a little bit ahead of myself here. I've got a couple other source files that I'm using. Let me take them out temporarily. We're going to be coming back to these a little bit later on. Now, when we build and run the application, we can see that using our basic geometry, we have our circle, our square, our triangle, our text box, and our text grid, all changing color dynamically at runtime. Now, this is nice, but this is also going to be based off the assumption that we're only going to have primitives inside our GL Studio application. What if we want components? This creates a problem. Let's go back to GL Studio. In here, we have SetColor Recursive. As I mentioned at the top, we know that all components derive from component base. So we have component base as component equals dynamic cast. And we'll try to cast it to a component base pointer. Okay, this will work just fine. We'll add one more else if. Else if it's a component, but now what? The problem is, all all of our components are highly specialized classes. I'll go ahead and bring a couple of them in to demonstrate this point. I have two, and I'm going to have to resize them. As an aside, while I place and size these components, all the components that I'm bringing in right now are available in the bonus tool pack, which is available on the customer support site. I'm going to use our calculator component and a simple text output component. Let's kind of place these into our scene, and then just for simplification, I'll go ahead and put them in their own group. Group these into a group called components. So we have our two components. We know they derive from component base. However, component base itself doesn't have any specific method that I can call that will allow me to change anything inside these components. This is a job for a custom base class. Our custom base class, essentially all it will need are the same two methods we wrote here, a set method for the color, and then the recursive method for SetColor_Recursive. We know those are the only two things we need, and to save some time, I've actually already created this. We have colorChangeBase.h. Looking at this code, a couple things to look at. The first of which, I've included all of the necessary includes for my project. If you were to take this colorChangeBase application, use it in your own, which you're more than welcome to. I'll be supplying this header file at the conclusion of this webinar. You would want to add any other components that you might be using. I have component base and color for the use of components. And then the objects that I'm actually setting are group, GLS text, and GL polygon. Scrolling down a little bit, we have our colorChangeBase class, which derives from component base, since we're a component. We have our single color value. And then we have our two methods. We have a method called color, which takes in GLS color by reference. We're going to set our color, and then we're going to call SetColor Recursive, passing it objects, which once again we have, and our address of value. SetColor Recursive does the same thing that it did before. The only difference is I've made a change here. Instead of calling display object or component base, I'm calling a color change base. I can do a dynamic cast to a color change base on a component. And then, if this component is indeed a color change base, I'll call that color change base's color method, which I know it has. So how are we going to use this? We have color change base, which derives from component base. So any components that we're going to want to change color of are going to have to be derived from that color change base. How do we do this? We'll go back into GL Studio. The first thing I want to do is make these changes here. First, I know my SetColor Recursive will need to be based off of a color change base and not a component base. So I'll make that change. Down here, else if comp, now I know since I'm deriving from a color change base that that component has a color method, which I could pass it, just like everything else, a dereferenced color. So let's go into our components. Once again, for the sake of saving time, I've already done these steps for us. We need to do two things to our components. One, inside the header file, we're going to want to include our base class. And then, if we go to the Generation tab, we have a checkbox down towards the bottom for User-Defined Base Class. We check the User-Defined Base Class, and then we supply the name Public Color Change Base. So we're saying that our component is derived publicly from Color Change Base. We'll make sure the same thing is true for our other component. Sure enough, it's User-Defined Base Class. We specify Public Color Change Base. And then, in the header file, we include our base class. So now, stepping through the code just one more time. We go into Calculate. Calculate sets our red, green, and blue values, calls color. Color then immediately begins SetColor Recursive on our topmost object, our parent group. This group will first find its group of text objects. Set the color as we had before. We come back out of this group, we open up our primitives group, it will set the values of the fill color and line color for the ellipse and the two polygons. Comes back out, finds our components. It will go into our components one at a time, and then run pretty much through the exact same thing on every single one of our objects inside our components. As an aside, GLS push button derives from group. So it would actually go in here and actually change our GL polygons in here. However, since we're using a texture, the line color and the fill color are irrelevant. Same thing inside GI_0021. The only thing that's going to be changed here is the text box, because everything else is actually using a texture. So let's go ahead and test and see if we did everything right. We'll generate all of our source code. This time we're going to get a few more source files generated. We'll have GI_0005, and we should be getting GI_0021 as well. Come back into our source. Let's try this just one more time. Remove these. Happens sometimes when you have multiple files, you tend to grab them from the wrong places. In this case, I'm grabbing from a different folder, a folder I was using to do testing work this morning. So let's go to Webinar, Tech Tips, Color Change. And we'll grab the GI_0005 here and the 0021 also located here. Quickly place these objects. Now we know we're in the right place. Grab 21. Slightly resize it down. And bring it in. There we go. So now when we go to generate, quickly get our source code. So we've got our color change. We have 5. Let's go ahead and also make sure that we've generated code for 21. Now if we go back to our source, okay, once again it's generating to the wrong place, but that's okay. We can work around that as well. We'll go ahead and go back into our solution. Okay, Solution Explorer, we'll go ahead and add some source files, existing items. This time we'll go to where I was actually doing my testing work, because that's where everything was generated to. Here's our GI_0005, GI_0001. Add those to our solution, and then once again, assuming we didn't make any mistakes along the way, as we build and generate our code, we'll go ahead and run it, and then once we've run it, we can actually see that not only are we actually changing our actual primitives, we're also going to be able to go into components and change their primitives as well, because they're derived from a common base class that we know how to handle. So we're linking, we build, we run, and as we can see, our text displays, like I said, these are the only non-textured objects in our components, are changing along with everything else at runtime. So once again, that will conclude this webinar. Once again, my name is Andy Rossiter. It's been a pleasure. Thank you for coming by, taking a look. Hope you learned some today, and we'll be looking forward to seeing you again next month.